Welcome to the deep dive. Today, we're jumping into the world of professional digital signage, specifically video walls.
That's right. We're looking at the hardware that makes those huge custom displays possible. Think giant screens in lobbies or control rooms.
Exactly. And you know how one image can stretch across, say, 9 different screens perfectly? That's what we're digging into.
Our focus today is a specific piece of kit, the WolfPack video wall processor. The part number is HDTV-TVW110.
Okay.
We're going to break down its specs, its capabilities, and really understand how this one sort of plug-and-play box manages up to 9 screens.
And the goal for you, the listener, it's basically a shortcut to understanding the core tech behind these big display systems. It promises simplicity for what seems like a really complex visual setup.
And just for context, the current price we're seeing is around $899.95.
Right, gives us a sense of its market position. Okay, let's get started. Fundamentally, what's the main job of this WolfPack processor?
At its heart, it's a smart splicing processor. Simple as that, really. Meaning it takes one video input source, could be HDMI, DVI, VGA, even older composite video, or files directly from a USB stick.
Okay, flexible inputs.
Yeah, very. And it takes that single source, processes it, and then splits the signal out to drive up to 9 separate HDMI displays.
9 outputs from one input.
Yeah.
And the resolution, what's the maximum we're talking about here?
That's key. The maximum output resolution for the entire wall, mind you, is 1920 by 1080p. Full HD.
Full HD across potentially 9 screens.
Exactly. So, if you're doing a 3x3 grid, each individual screen is only showing a fraction of that 1080p image.
Yeah.
About 640 by 360 pixels, roughly.
Okay, so definitely not about super high-res detail on each screen. It's more about the overall impact, the big picture.
Precisely. It's designed for environments where people are viewing from a distance. The documentation mentions retail, clubs, trade shows, control centers, building lobbies, places where you want big dynamic visuals.
Right. Makes sense. And it mentions HDCP compliance. Why is that important here?
Oh, absolutely vital for commercial use. HDCP, high bandwidth digital content protection. It's basically the anti-piracy handshake for digital video.
So if you want to play a Blu-ray or stream protected content.
Yep. Your whole system needs to be compliant, otherwise you just get a blank screen. So for retail or entertainment venues showing commercial content, it's a must-have.
Got it. And just to be clear, this $900 price tag, that's just for the processor box itself, right?
Correct. You still need to provide the actual TVs, up to 9 of them, ideally matched models, plus all the wall mounts and cabling. This is the brain, not the whole body.
Okay. Good clarification. Now let's talk about the really interesting part, the configurations. The specs mention 27 different ways to build a wall.
Yeah, 27. It sounds like a lot, but it highlights the versatility. This is where the smart splicing really comes into play.
So it's not just your standard squares.
Not at all.
Right.
I mean, yeah, you have your basic 2x2 or the full 3x3 grid, which seems to be the standard they push. But you can also do like really long horizontal strips. A 1x9 configuration, maybe for tickers or wide banners.
Like in a stadium or transit hub.
Exactly. Or, flip it the other way, you can do super tall vertical columns. Think 9x1 or 5x1.
9 screens stacked vertically.
Yeah.
Wow.
Or even asymmetrical layouts like 3x2, 5x2, 2x4, all pre-programmed. You select it from a menu.
That sheer number of options.
Yeah.
That's the main selling point then, hardware flexibility.
I think so. It means you don't need complex software or a dedicated PC setup just to create these unusual shapes. The box handles the geometry.
And the input flexibility we touched on earlier, accepting HDMI, DVI, VGA.
And that USB port. That's pretty neat for quick setups. Like at a trade show, you can just load your video or image files onto a USB stick, plug it in, and the processor can play them directly.
So you might not even need a separate computer or media player sometimes.
Potentially, yeah. For simple looping content, it really streamlines things.
Okay, that makes sense. Let's move on to the practical side of actually building the wall. Plugging things in is one thing, but reality hits with the hardware especially. The bezels.
Ah, yes, the dreaded bezels. The black borders around every screen.
How does this WolfPack deal with those? Because if you just tile the raw images, the bezels create gaps, right? The picture looks broken.
Exactly. And this is a crucial feature. It has what's called bezel compensation or bezel correction.
How does that work?
Basically, you tell the processor through its on-screen menu how wide the bezels are on your specific monitors.
Okay.
And the processor then digitally adjusts the image slices. It effectively discards the part of the image that would be hidden behind the physical bezel, ensuring the visible parts of the image line up perfectly across the screen edges.
So it creates the illusion of a single continuous image, even though it's crossing those physical gaps.
Precisely. And it says it can accommodate pretty much any bezel width, which is important because different monitors vary. You configure it via the OSD, the on-screen display.
Clever. And speaking of clever physical adjustments, there's this 180-degree rotation feature mentioned. Why on earth would you want to hang a screen upside down?
Mm-hmm. It sounds weird, but it solves a very specific and annoying installation problem. Monitors often have a thicker bezel at the bottom.
Right, where the logo or controls might be.
Exactly.
Mhm.
So if you stack screens normally, one above the other, you get this extra wide gap between them because you're putting a thick bottom bezel against the thinner top bezel of the screen below it.
Ah, I see uneven gaps.
Yeah, it looks messy. So this feature lets you physically rotate or invert one or more of the screens by 180 degrees.
So you can put thin edge to thin edge.
You got it. You hang the top screen normally, then hang the one below it upside down. Now their thin top bezels are meeting, minimizing that visible gap. Makes the whole wall look much tighter, more seamless.
That is smart. A very practical, installer-focused feature solves a real-world headache.
Definitely. Again, configured in the OSD for each output port as needed.
Okay, so we've got the signal splitting, the layout flexibility, the bezel fix, the rotation trick. How do you actually control this thing day to day? It's plug and play, no software needed, but you still need to manage it.
Control is pretty straightforward, very direct. You've got buttons right there on the front panel of the unit itself.
Okay, physical buttons.
Yep. And it also comes with a standard IR remote control. You use either of those to navigate the on-screen menus we mentioned, the OSD or GUI, to set everything up.
So point and shoot control, essentially. Now, there was a slight confusion in the source materials we looked at regarding control methods.
Ah, yes.
Yeah.
The specs sheet mentioned RS-232 control as a possibility.
Which is a common serial port for automation systems?
Right, but then a feature bullet point explicitly said it doesn't support RS-232 control.
So what's the takeaway there?
Given the emphasis on plug and play and the IR remote, the most reliable interpretation is that it primarily relies on the front panel and the IR. The lack of robust RS-232 support kind of reinforces its niche.
Meaning it's not really designed for complex integration into, say, a big building's automated control system like Crestron or AMX.
Probably not its strong suit. It seems geared towards standalone setups, where someone can just walk up to it or use the simple remote, less about deep network integration.
Okay, that positioning makes sense. And finally, scalability. 9 screens is a lot, but what if you need more, say a 4x4 wall, 16 screens?
The system is designed to be expandable. You basically daisy chain multiple units together.
How does that work?
You'd buy a second WolfPack unit, you take the HDMI output from the first controller,
Okay.
and connect that into the HDMI input of the second controller. Then you use the OSD menus on both units to configure them to work together, extending the video wall grid.
So Unit 1 handles the first part of the wall and feeds its overall image to Unit 2, which then handles the next section.
That's the idea. You can keep adding units to build larger and larger walls, theoretically.
But each unit is still, what, $900? So a 16-screen wall needs 2 units. That's nearly $1,800 just for the processors. Does that scale cost-effectively compared to maybe PC-based solutions for really big walls?
That's the trade-off, isn't it? It probably remains competitive for medium-sized expansions, say up to 16 or maybe 25 screens, because you're avoiding the complexity and potential cost of high-end graphics cards and specialized PC software.
Right.
But you're still limited by that core 1920 by 1080p resolution across the entire composite wall, no matter how many units you chain. You're scaling the size and flexibility, not the pixel density.
Which brings us back to the core value proposition. Okay, let's wrap this up. Key takeaways from this deep dive.
I'd say the WolfPack processor, this HDTV TVW110, is really a strong example of a cost-effective, hardware-focused solution for video walls. Around $900 gets you incredible layout flexibility, those 27 configurations.
And it tackles real installation problems head-on with things like the bezel compensation and that clever 180-degree flip for tight screen gaps.
Exactly. It's built for speed and simplicity in deployment, especially for digital signage and entertainment spaces where impact matters more than, perhaps, ultimate resolution.
Plug-and-play power for complex visuals. All right, that leads nicely into our final thought for you, the listener, to chew on.
We've established that the system prioritizes screen count and configuration flexibility, but caps the overall resolution at 1080p, regardless of how many units you stack.
So the question is, in a world where 4K displays are becoming increasingly common, even standard, does this focus on flexibility over pixels give the WolfPack a limited shelf life?
Or Put another way, is there an enduring market for this kind of simple, reliable, hardware-based approach, especially at this price point, even if it means sacrificing that cutting-edge resolution? Does good enough resolution plus maximum configuration freedom still win in certain segments?
Something to think about. Does the need for simple setup and physical control sometimes outweigh the push for ever higher pixel counts?
That's the question. Where does the balance lie for different applications?
That's our deep dive for today.